I would like to welcome you into my Introduction to Finite Elements class and this spring semester. I look forward to working with you during this semester, and I hope you're going to achieve the course goals and objectives. That I will take the time this morning to introduce myself, and I look forward for each one of you introducing her or himself on the Canvas course discussion board and sending me an email to make sure we get to work together and know each other better and make sure we achieve your course objective. I'll be working towards that. With that being said, I would like to share my screen and show you the Canvas course page that I hope you all have access to. So with this being said, I'm gonna share my screen here. So when you go to the Canvas, the course on the Canvas, you are gonna see what I'm seeing right now. Has here the Intro Finite Element Method, Spring 2021 Online Synchronous. And you can see that here it has me as your instructor, Fadi Barsoum. That's me. And start here, that would take you through the different modules of the class, the syllabus, the course information, and the tentative schedule. So I will take this opportunity first to introduce myself, and then we're going to get into more course specifics. So if I click on my name here, Fadi Barsoum, you get another picture of me here. And for those of you that never met me before, I'm a professor and the program coordinator with the Mechanical Engineering Department at Embry-Riddle, Daytona Beach campus. I've been with Embry-Riddle for more than 15 years, and my office is located in the Mechanical Engineering Suite when we have access to these, not this semester at least. So for now, you can best reach me by email. So you have my contact email here listed, and I look forward to be available to talk with you as needed. As I'm going to mention, this is an online class that is listed as synchronous because we have meeting hours reserved for Tuesday, Thursday, 9:45 to 11 a.m. So these are our meeting hours for this semester. I'm going to talk more about that. A little bit about myself. I joined Embry-Riddle in January 2005 after working in the industry for more than 10 years. While at Embry-Riddle, I also got the opportunity to serve the NASA Orion Space Program at NASA KSC, Cape Canaveral, Florida in 2015. And in 2010, I served as a research fellow to the US Navy, investigate the failure of the H-60 Navy helicopters at the Naval Air Station in Patuxent River in Maryland. And in the 90s, I also served the NASA Space Shuttle program, also out of KSC, Cape Canaveral. So I was really privileged to work on some of these interesting projects. Prior to 2005, I worked in the industry in several capacities. Mostly I was using finite element methods. I worked both in development, quality assurance of commercial software packages, as well as implementation, teaching short courses in the industry, and as a consultant to several companies. Just to give an example, one of these was General Motors back in the late 90s, when they were trying to build their first fully parametric finite element model using, at the time, Pro Engineer and Pro Mechanica, now is known as Creo. So I was working for PTC, the mother company for Pro Engineer and Pro Mechanica at the time. And I helped General Motors to build this body in white for their mid-size vehicles. And this was one of the interesting projects, in addition to several others for different clients in multiple industries. Right before joining Embry-Riddle, I was working on the Joint Strike Fighter program. I was also approving engine components for the Strike Fighter, reviewing the works of different vendors, including finite element modeling, as well as experimental validation that their parts would pass the specs required by the government. I am involved in research that includes finite element, structure health monitoring, non-destructive techniques, fatigue, structure dynamics, and vibrations. And I am still working with my students to publish papers, as well as the receiving grants and recognition for the work that I'm doing. Personally, I am married and have 2 children that are also doing virtual school, and during this time, of course, only. Like some of you, I am not on campus this semester, but I'll be happy to meet with you via Zoom as needed. With this being said, I would like to move on to emphasize the academic integrity policy that Embry-Riddle have, where everyone is committed to maintain and uphold intellectual integrity. And I think you've seen this quite enough, but basically we all abide to keep this academic integrity policy. I would also like to mention that all the work that you are going to be presenting should be your original work. Yes, collaboration is expected and encouraged while working on the homework, but at the end, please make sure that the work that is presented represent your understanding and really help you learn the material and get you ready for the exams where you're going to be working without any collaboration. Please make sure to pay attention to the due dates for homeworks, exams, because I will not expect homeworks to be submitted past the due dates. Should you foresee anything coming up, procedures, illness, duty, please let me know ahead of time so we can plan accordingly. So this is a little bit about myself. I would like to go back to the course homepage and go to Start Here. And this will take me to syllabus and important information. Before you begin the course, be sure you have read the important course information below. If you have any questions, be sure to contact your instructor. And this is one of the reasons we're having this one-on-one meeting, because I would like to personally answer any questions, make sure we are all on the same page, understand what is expected, what is the responsibilities, and what are the expectations both ways, to make sure we can work together closely and successfully to achieve the learning outcomes. So the very first thing you're expected to do is to read the syllabus. And remember, as usual, these syllabus serve as a contract between us to make sure that we understand how things are going to work throughout the semester. Before I click on this and open that, as you can see here, there are a few things that are highlighted that I would like to take a few minutes to go over. And I think they're listed also again within the syllabus. but because they are important information for this class, they are mentioned on this very first page. And one particular thing is, what is this synchronous online learning? So the class is listed as online synchronous. So yes, it is an online class where most of the time you will have pre-recorded lectures that you can watch at your convenience. However, there still is a designated time for the class, which is Tuesday and Thursday from 9:45 to 11. And these times need to be reserved for this class throughout the semester. They are going to be used to hold Zoom class meetings like the one we're having today as needed. So you're going to get announcements beforehand. You're going to have enough time to know that there is a class scheduled during that time, in addition to taking exams or quizzes during the class time, as is going to be announced beforehand. So that's the idea of having an online synchronous, to allow us all to be available during this time, to use this time slots as needed. So please make sure you continue to reserve this time for this class. Please pay attention to the due dates for the homeworks and for the exams. And I would add not only due dates, but also due times. And keep in mind that when you are submitting your work electronically, occasionally you're going to need, if you have handwritten work, you will need to scan it. And please make sure you use a scanner or an app that produces quality PDF files. No photographs are accepted of your work. I need to get something that is clear to be able to read and grade. And please make sure you give enough time to use the scanner or the app to scan all your paper and upload it to the Canvas before the due time. So you make sure you want to submit it on time. I recommend communicating via the email tool through Canvas with me directly or my TA as needed. As far as learning expectations, you are in order to achieve the learning outcomes, you are expected to spend as much time each week on this online course as you would in a traditional classroom-based course, which typically for a graduate course, I would say you're looking at, I think 10 is a minimum, but typically probably 15 hours. So 10 to 15 hours per week, let's say, is a good range. It is your responsibility to read the syllabus and other information provided by the instructor and follow the instructions contained. Please feel free to ask any questions if anything is not clear. And again, today, please feel free to interrupt me at any time and let me know if you have any questions. In a rare situation where there is an illness, an incident, a temporary duty, please make sure to contact me immediately to see if we can do anything, because it's very difficult to play catch up on these classes if you fall behind. I recommend that you keep electronic copies of all the material and assignments that you are submitting for this class. As far as communication and interaction, email is the preferred way, and you can please make sure you're sending the email from your Embry-Riddle mail account or the email feature within your Canvas course. When you send an email, you do not always expect an immediate response. I would try to respond as quickly as possible, but if for any reasons you don't hear back from me within 48 working hours, please follow up with me. That's absolutely fine. With this, I would like to go to the syllabus, but before I do that, I'll be happy to take any questions if you have any questions so far. feel free to unmute yourself and talk. Okay, if not, let's move on to the syllabus. So you should be able to download a PDF copy of the syllabus to have with you at all times. For now, I'm just gonna go over, I'm gonna here zoom in so you can all see it, so you can see the syllabus. So we have 8 pages of this syllabus or agreements that we wanna make sure we can all follow along. At the beginning here, you have my contact information. This is the 3-credit hour graduate course, ME 514 or AE 514. It's online synchronous. And again, I repeat, while recorded lecture videos shall be made available on Canvas that you can see at your convenience, class meeting time shall be reserved each week. These periods shall be used to take exams and quizzes as scheduled or hold Zoom class meeting as announced. Please reserve these times for this class through the end of the semester. So we are only going to be meeting as needed and as announced. Should we need to go over a homework problem, do an extra example, something along these lines, I will let you know. I'll be happy to meet via Zoom by appointment for office hours as needed. As far as required course material, I'll be using the textbook, a first course in the finite element method by Logan that is published by Cengage Learning. And this is the 6th edition that I have. Recommended prior knowledge is matrix algebra, methods for solving simultaneous linear equation, basic knowledge in MATLAB. And during the first week, you're going to be expected to review some of this matrix algebra from your book, from the appendices, as I'm going to show you shortly. Recommended software is MATLAB, and it's also recommended that you use one of the commercial finite element software packages like Abacus, Nastran. Many of you here have used either Nastran or ANSYS Workbench, depending on whether you get your degree in mechanical engineering or aerospace engineering. But one of these can serve should you want to verify a problem using any of these commercial software packages. However, this class is not intended to teach you a commercial software package, but rather to teach you the theory of the finite element method. With this, I would like to go over the course description. Basic equations of the theory of elasticity. So we're going to be working with elastic structures, energy principle, formulation and assembly of stiffness matrices and load vectors for elastic solids, modeling considerations, solution methods, computer implementation of the finite element and stress analysis procedure, interpretation of computer solution and design application. The course the course is designed to give you basic working knowledge of the finite element method and its limitations as applied to the static analysis of certain elastic bodies, so mainly linear analysis. And we are going to look at elements that uses bars, 2D, so can be applied to rods, membranes, planar solids of revolution and plates. The procedures are essentially those programmed for digital computer solution of large and complex stress analysis problems. The goal is not to learn how to use specific finite element programs. So again, the focus is going to be on the theory. Upon the completion of this course, you should be able to derive a stiffness matrix for an element, assemble stiffness matrices to obtain the general stiffness matrix of an assemblage. And I know this is maybe new to some of you. Some of you have had an introduction to finite element before, so you can relate to some of the topics listed here. but if you do not worry, we're going to cover this material in this course. Use appropriate displacement functions. Use transformation matrices to derive stiffness matrices of elements arbitrarily oriented in space. Calculate stress, boundary condition. Use potential energy approach to derive stiffness matrix. Use the Galerkin's method to derive a stiffness matrix. Identify limitation of different elements, how to use them and how to interpret results. Apply symmetries to simplify problems. Demonstrate how to treat distributed forces. Use the isoparametric formulation to solve complex problems. So I really hope that you will be able to get out of this course something that some of you may be applying on their jobs while they are serving as a finite element analysts or using a finite element software package or moving in this direction towards career in finite element modeling. I know some of you are also doing research and may have a need to write their own code to solve specific problems. And we're going to talk more about that as well. So while we work primarily to achieve the learning outcomes, it is also important that we understand the grading policies to make sure that you all achieve a high grade in this course. So in this course, there are going to be major assignments, specifically 2 exams and a set of homeworks. Homeworks are weighed at 30%, exam 1 weighed at 35%, and exam 2 at 35% to make a total of 100% of your course grade. Your assigned grade is going to be based on the following scheme. A and 90% and above is an A, 80% and above is a B, and 70% and above is a C. And I know everyone here is trying to stay within an A and B, so let's make sure we work towards that. This is a graduate course, so this is just a reminder, but I know you all know that, and I expect that all the work that's going to be submitted is going to be presented in a professional manner like you do in the contemporary workplace. It has to be legible and clearly presented. Please make sure to box your final answers. Begin each problem in a new page, states the problem given, inputs, make sure you use units, show all details, show the schematic diagrams of the problems. Of course, if I cannot follow the work, it will be very difficult to assign a grade. So let's make sure we all avoid that. As far as the exams, the solution of the exam must be the work of each individual student taking the exam. You may use a textbook or references as going to be instructed for each exam. So some of the exams are going to be open books, and I'm going to let you know when the specific material is used, you want to reference this material, and it must be noted in the solution. Of course, if the exam is open book. If the exam is closed book, I maybe give you an equation sheet, and then this is the only thing you're allowed to use. So for an exam, you are not allowed to have any discussions or talk about the exam with anyone else. There is going to be one exam in module 5 and a second exam on module 12 of this course. So we are going to have 12 modules in this courses, and I'm going to talk about the modules after we go over the syllabus. When you take the exams, please box your final answers. When done, use a quality scanner to scan your answer. Label your file, please, with your last name and upload your solution in Canvas. If you're downloading an exam or taking a quiz through Canvas, when you do that and submit your solution with your name on it, you agree to abide to the Embry-Riddle honor code. And of course, you can review the Embry-Riddle academic policy again. This is more on the homework assignment. I think we covered that already. I think there is some repetition here. I'll make sure to fix that on the syllabus. Okay, we went over that on the online synchronous learning, and I hope this is clear for everyone, but if you have any questions, I'll still be happy to answer these. Email also is the preferred method of communication. This is the Embry-Riddle Academic Integrity Policy. We want to maintain and uphold intellectual integrity. All the students, faculty, and staff have obligation to prevent violations of academic integrity and take corrective action when they occur. So this is something that I hope we never have to deal with, but this is just to make sure that we all understand the policy and we do not have to deal with any of these corrective actions during this course or during this semester. As far as the course schedule, here is a list of the 12 modules that we're going to be covering throughout the semester, and the title or topic of each module, and the activities, the things that we are going to be doing during each module. Of course, you can also see that by going to the modules on the Canvas site. So this is the syllabus, and I will make some edits today after class to make sure I remove some of the duplication that I just noticed and upload a new syllabus that you should be able to download and keep a copy with you. Before I go to the Canvas site, I would like to give you the opportunity to ask questions. Should you have any questions so far?
Yes, hello. Christian Mueller. I got a question.
Of course.
So I saw that there's a quiz due on the 28th with 3 attempts. Does that just take the standard best attempt when you do that, or is it an average, or how does that work?
Actually, I would like to take your best grade.
Perfect. Thank you very much.
I hope that's the last attempt, of course. Right? That's the purpose. You take another attempt to get a better grade. So I think the last attempt is the one that's going to be taken. Is that clear?
So it's not the highest attempt, it's the last attempt. Understood.
Yes.
Thank you.
You're welcome.
Sam, I just have a question. So is each module, is that representative of a week in the class? So like module 1 is week 1.
Thank you so much, Sam, for this question. Because actually, not always. There are a couple of exceptions for a good reason. And because of that, I just went here to the modules, and let me make sure I am on the, okay. So this is what you see for modules. So if you go to the modules on the Canvas site, you see here like module 1, and next to the module 1 at the end, there are dates. So like here, because there is some work that we're going to be doing, including going through the mathematical background that is needed. We have like the first 9 days to work on this module and complete before we complete the quiz. So the quiz is scheduled for January 28th, and that gives you time to study the material before you take the quiz. Because I know some of you already learned about matrix algebra and system of linear equations, and others may need to refresh that. And that's why there is this reading assignment about the mathematical background. But back to your question about the dates, next to each quiz, it's almost, there are dates here, and you can see that the dates are gonna vary depending on how much time is expected this module is gonna take you. So like you see, like module 3, you have like 12 or 13 days to complete module 3. Like module 3 and module 4, I would say are, module 3 is by far the longest, but past that, I think each module is pretty much a week or less, maybe 5 days time frame. So you have the dates where you know that this is the time you're expected to be working on this module. I also would like to take this opportunity to add that pre-recorded lectures are going to be included within these modules prior to the dates when you are expected to be working on these modules. Does that answer your question, Sam?
Yes, it does. Thank you.
Good. Any more questions?
I guess so for on campus, this is Sam again. So the computers on campus, do they have ANSYS, or I assume they have ANSYS and MATLAB? Some of them have ANSYS and MATLAB already installed on them.
Yes.
Some I can't. Yeah. Okay.
Yes. Typically, the the lab computers should have ANSYS Workbench and ANSYS and MATLAB. And as some of you know, you are, as a student, you are eligible to download a free copy of ANSYS to install on your machine. And we're also working with IT to make ANSYS available remotely. For some of you, should you used to use ANSYS. Again, using the software package is not going to be the focus in this class. We're going to focus more on the theory.
Hey, this is Christian. I've got another question. So you said to make ourselves available for the regular class meeting times. Are we going to be having a Zoom lecture in addition to the modules we go through at our own pace, or is it just office hours?
Thank you, Christian, for this question. We are going to do that as needed. So let's say after completing the modules, I'm receiving like common questions from many of you. Then I would like to take the opportunity, like I will notice that there is a difficulty with any of the homeworks. So I'm going to call for a meeting where we can all get together and I can work something that we can all share together and do questions like we're doing right now. So this is the reason we have these time slots reserved for that purpose.
Okay, so you'll call for a meeting if we need to come back to the Zoom call.
Correct.
Okay, so as of now, on Tuesday, there won't be a Zoom conference.
That's right. That's right.
Understood.
So Tuesdays and Thursdays, we're not going to be having these meetings because you're going to get your lectures pre-recorded within the modules. So your lectures are going to be embedded in the modules. So you can, this gives you the flexibility to watch the lectures at any time that is convenient to you during the time that is designated for this specific module.
Understood. Thank you.
Also, I would like to mention that whenever there is an assignment, I would advise you to start early on. As soon as you start the module on the date that this module is expected to start, familiarize yourself with the assignment. You're not expected, of course, to work on it until you have learned the material by watching the videos, going through any examples, and then you should be able to work on the assignment. But please do not leave it towards the end because some of these assignments are time demanding and you want to make sure you give yourself enough time to complete these assignments. Good. These are all very important points. I really appreciate the questions that are coming and I'll be happy to take any more.
Hey, Professor, it's Hamam.
Hi, Hamam.
Hey. Speaking of assignments, are we going to have one assignment per module, or is it possible that we're going to have more than one?
Okay, good question. So if I go right now to the course summary, and if we look at it right now, you can see the dates and the assignments throughout the semester. So on January 28th, there is the quiz that we were talking about, and it is on matrix algebra and systems of linear equations. Then the next is going to be February 9th, then February 21st, then March. And you can see here the number of the module. So this is module 1, module 2, module 3, 4. For 5, you do have, we're going to be doing our first exam within module 5, as well as there is a homework on module 5. There is a homework on module 6, but there is no homework on module 7. There is for module 8 and for module 9 and for module 10. So I would say there is no homework for module 11. So I would say, and then we're taking our exam 2 in module 12. So I would say pretty much there is almost one assignment per module. Pretty much. For module 5, there are 2. There is an exam and an assignment. So this is a good place to see your assignments, as well as how your grade is going to be calculated.
Perfect. Thank you.
Good. More questions? Okay. I hope that you will find that the course Canvas site is intuitive and is informative. So like you've seen, I navigated quickly to the summary to get this. And even from the summary, I still can have access to the syllabus and the important information. And this is where I should start. So if I go like start here, this takes me to the modules, which this is one way to get to it. Or if you go to the home page, I can go to start here and click to next. We've already done this intro, the bio. Yeah, and one of the things that I would like you to do, some of you already completed that. Like I introduced myself to you this morning, I would appreciate it if you take a few minutes to send me an email and introduce yourself. One of the assignments you have on module 1 is also to introduce yourself to your classmate using the discussion board. That I think would help to, while we're doing this class online, to kind of establish that sense of a group that can possibly work together or collaborate or interact to the benefit of everyone. So I will be looking forward to receive an email from you. This is kind of introducing yourself and acknowledging that you've seen the syllabus and learned about how this course is going to be set, and you're agreeing to everything we discussed today. Next, I have here some links to MATLAB training and finite element software package that you can use to check these out. Then here is module 1, and this is basically overview and objectives, some of the things that we're going to be going over today in our class, since we are meeting on person. Then at the end of this, you want to be able to perform matrix algebra, solve system of linear equations, recall the equations of linear elasticity theory, which you are going to find, of course, after you're going to find like where I intend to embed a lecture video. You're kind of find like a broken link, and this is where I'm going to be uploading my lectures. There are also some lecture notes from a prior course that were compiled by Dr. Rollins, pretty much along the same, like similar to the topics that we're going to be going over together in this class. I thought that might be useful, so I provided a link here to it. But as you move on into module 1, here is 1.2. This is where you get to introduce yourself on the discussion board to other people in this class. And again, some of you already did that. So this way we get to know each other. So if I click next, you have a little bit of a history of the finite element method. And then you have the reading of the mathematical background. And this reading is out of your textbook, appendices A and B, A for matrix algebra and B for methods for solution of simultaneous linear equation. And I might provide some additional material as needed. And after that, you should be ready to take the quiz here. And finally, you are gonna read Appendix C, which is kind of a review on equation from the elasticity theory that we're gonna be using some of it in this class. And this image, by the way, is the 5th edition of the textbook. So this is in case someone have the older edition. But I have the 6th edition that I'm using personally, and I expect most of you are gonna get hold of a 6th edition copy, whether electronic copy or a hard copy. So this here will conclude the module 1. So at the end of the module, you have a module 1 wrap up and just kind of put together what we've done. And then you should be ready to go to module 2. Now, please note that when you go here, you do not really see the dates. But if I go to modules, it tells you the dates of that you're expected to be work on a specific module. I will also try to put announcement to remind everyone at the beginning of a new module that during these dates we should be working on which topics, and try to make sure we keep the communication channels open as we go through this journey together. Okay.